Thank you very much for being here. Thank you to the organizers for having me. This is a unique opportunity to get to present to a bunch of people who were on all of the syllabi that I was reading in grad school, so I'm glad to be here. And thanks in advance to Bronwyn's, what I'm sure will be awesome comments. So the motivation for this paper, I think, is an uncontroversial claim that a lot of people have very strong opinions on how well science is functioning. And, but a lot of these strong opinions, I think, are often rooted in a lot of anecdotes and personal stories, despite scientists wanting to do quantitative analyses. And I think the high-level goal of this particular paper and effort of ours is to get a sense as to how much better could things be in general within the world of science. And I'll try to be more formal about that in a minute. But just to fix ideas in some good Econ 101 way, we want to think about, the goal here is we want more science, more good output from science, and the aggregate output of any market depends on, of course, how much inputs go in. It also depends on the productivity with which those inputs are turned into outputs, our little parameters on our production functions. And then we want to also think about allocative efficiency, is the extent to which all of the marginal products have been equated, because that's the world in which we're maximizing total output. Now, as most people in this room know, doing anything like this has historically been extremely difficult for lots of different reasons. One, it's hard to see inputs, and it's really hard to see outputs. It's really hard to see variation, to identify these parameters. People in this room have done amazing work to identify the average effect of the marginal dollar into science. And ideally, we want to get to the point of knowing each scientist's effect of giving them more resources, which is what we're going to try to do in this paper. But then we also ideally want to be in a position where we can compute some counterfactuals that say things like, if we reallocated inputs, how much more science would get done. Of course, these are not new questions or challenges to be faced. These were quotes from the James Adams and Zvi's paper, looking at productivity in academic research, which is what we'll be focusing on. And I think my favorite one here is the measure of what constitutes a scientific paper makes for an elastic yardstick of scientific achievement. And the first one is basically about inputs are hard to measure. And this paper, we're going to have a new survey to try to see inputs better. And the second problem is that outputs are hard to measure, and we're going to use theory to not have to see outputs at all. So, all right, so buckle up. So the two research questions we're going after is, what is the distribution of productivity across scientists? And number two, once we have that, how much more scientific output could be produced if we optimize allocations given some objective? There's a third lingering question, which I won't touch today, is if you know these things, you can start to uncover who are the scientists that appear over or under-resourced relative to these objectives. The way we're going to do this is with, like I said, a new survey where we have data on scientists' inputs, the constraints, namely on their time, as well as their willingness to pay for more inputs. And we're going to use a model of scientific production and consumption. This model is going to be a model of us, and we're going to convert those willingness to pay for inputs into each researcher's own beliefs about what I will call their total factor productivity. And then once we have that, we can actually solve for alternative allocations of inputs and see how much more science gets done. So the way I'll start by just giving you an overview of this survey that we did, but high-level takeaways that we have about 4,000 scientists across virtually all of what you might think of as research. That is including humanities, including astrophysicists, including economists. I'll show you some data to say that on observable dimensions, the people that respond to the survey look quite similar, very, very similar. We have some work in the paper to try to address unobservable selection into this that I'm not going to spend too much time talking about. But I want to give you some summary stats on who those people are. And there are some questions that are very qualitative about what they're producing to give you a sense of what do we all mean when we say output in science, but we're not going to use that data in our analyses. So the model of science is one where each researcher, each of us, faces a triplet that is our salary, some guarantee of funding from our institution or prior awards, and then required duties. Then we choose how to allocate our time across research, fundraising, and leisure. And in this model, it's going to come to a world where our choice about how we want to trade off our salary for these other things is going to be a function of how good we are at turning those inputs into outputs, which is another way of saying our own productivity. We do this by asking people questions of this form. What salary would make you indifferent between your current position and one where you had $1 million extra in research funding? So of course, you'd be willing to take a salary that is lower, and that difference in the two salaries would reveal your willingness to pay. Converting this all into willingness to pay, the median scientist is willing to pay, in our data, about 10 cents for $1 of research funding and about $68 for 1 hour less of admin. You can benchmark yourself against those. Then I'll walk through the parameter estimates. The utility function is very what you would think. Scientists don't like, they don't like everything but research, and on net they actually have positive utility from time spent on research between the consumption value of the output as well as just the very, very low disutility of work. We all love research, and that's what the model says. We find a high degree of productivity dispersion, which I'll get to in a second. Our measure of TFP and like what exactly to call this thing that we recover is something I think we'll be talking about, but it does correlate with traditional metrics like publication, citation output, but not perfectly, and I think that's on purpose, and I think that's because we're trying to capture something that is not necessarily captured in the traditional data. Then we'll wrap with the counterfactual allocations where we either try to move inputs around in a way that maximizes scientists' aggregate utility, which is nice for all of us, or one where we maximize social welfare, where we have to take some stance on how big the externalities of researchers' output is, and we'll get to those results then. Okay. First, I just need to give a big shout out to a number of people who have helped with the broader surveyed effort here. They're not co-authors on this particular paper, but we have other papers looking at this survey effort. So what do we do? Our population is basically all the big, fancy, good research institutions in the US, the 150 largest per R&D spending. And the people we are interested in is people listed on the website with the word professor in their title. The reason for that is very much the logistics of data collection. I can talk about, if people want to, about what that means in terms of sample representativeness. But we paid a lot of people a lot of time and money to go to every website and collect their information that was posted online. This happened over the course of about 2020 to 2021. We sampled by breaking people down into fields of study. There's like, I don't want to get too much into the weeds. We did use randomized incentives that were very effective at pushing people into or out of participation, which we'll use to do some sample selection, but I'm not going to talk too much about that. But as you all know, nobody likes to answer surveys, and so from 130,000 emails, we wind up with 4,000 people who reported a non-zero salary, which we need because that's something they're going to be trading off in our thought experiments, as well as spending more than 0 hours per week on research. So this is a graph to give you a sense just on observables, how different are our respondents relative to the sample that we got. The gray is the full sample that we sent the emails out to, and these are people matched to their publication record, their citations, their grants. These are all normalized and or converted into yearly flows, which is why you see numbers like 0.1 grants. And the people that completed the survey lined up very well. This was a terrifying graph to make, but very exciting to see. And like I said, we have a lot in there about trying to make sure these people are behaving and not a very unrandom sample. One of the other things we did was public universities post their salaries of their employees, and we had a team go through and collect that and match, and we find a very high degree of alignment between what people tell us and what their publicly posted salary says. A few key summary statistics to give you a sense of the data. There's the 5 broad fields that unless I say otherwise, when I say across fields, we're talking about these 5 broad fields. It's a relatively even spread. Average salary, $160,000, 40% full professors, 60% have tenure, mid-40s, almost gender parity, but not quite, and that certainly varies across field. And we also have data we have all sorts of data that I won't get into as well, but household composition, all sorts of other things. So input data. So here, this is what we asked the respondents to basically forecast over the next 5 years, approximately how much blah, 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 blah. And they had then reported to us, how many hours do you think you're going to work per week? How are you going to allocate your time? How much funding do you have guaranteed over that period, either because your institution just gives it to you every year or you have some pre-existing grants, as well as how much money do you expect to fundraise based on how much time you expect to spend on your fundraising efforts. And you can see super, unsurprisingly, very skewed funding data. The means are way above the medians. And again, that's because we have all of science in this data, so you're going to see a high amount of variation. So now this is the data we have on output. Like I said, we're not going to use this in our analysis, but it gives you, we're all researchers, so we all kind of know what scientists do. But in the survey, we asked people to rate on just a simple Likert scale of never, sometimes, always. What is the frequency with which you try to produce these different types of things? and what is the frequency with which these are the audience that you're trying to kind of produce those things for. And again, not like a controversial claim, everyone in this room already kind of knows and agrees that like scientists do a lot besides peer-reviewed papers. And again, just you can see this in this data, and that's another reason why we're going to try to not use that as any sort of ground truth about productivity. Now, okay, the fun part. This is the model of us. But before we get there, the entire intuition of this paper is like a very old and very simple concept that I just want to make sure is clear, because once you like are with this, then it is quite easy to understand the model that has a few more parameters in it. I just want to start with a stage where there's a single producer, I, and they have to choose some amount of inputs to produce, and we have a very standard looking profit function, right? Price is a function of quantity, which is a function of inputs, times quantity, which is a function of inputs, less the cost of acquiring that number of inputs. Now, I've been purposeful about the subscripts, and this because it's going to be kind of reflect the nature of our model, is that there's a common demand for all producers in the sense that the price that everyone faces is a homogeneous function of the output they produce. But we allow for flexibility in the production functions, QI, everybody has their own production functions, and we are flexible. We actually won't care at all about the cost function for reasons you'll see in a second. For tractability, the only little thing I'm going to do is instead of having everybody have their own unique production function like QI, for this example, let's just say there's a single parameter like a TFP that determines all of the heterogeneity in production functions. Great. Now, after they've acquired their inputs or made some forecast over the inputs they want to acquire given their beliefs, let's say we swoop in and randomly say, hey, we are now going to say auction off some amount of extra inputs, delta, that you could buy and add to your stock that you've already optimally chosen for. So that your total input level would be what your optimal choice was plus this new amount. Now, it's random, so like there's no way you would have known this is coming, and so you haven't optimized for it. The question then is like how much is each producer willing to pay for this marginal amount of inputs they can add to their input stock. Now, perhaps some of you might have already see where I'm going here. Your willingness to pay for each producer is a function of all the things we can observe and the thing we want to estimate, the alpha I. So if you know how much people chose the X star, if you know how much is being bought, if you know the demand function, if you know the general form of the production function, then you can get yourself the productivity. And just as like a simple math example, if you want to skim through that quick, like if your production function is a simple linear thing, the inverse demand function is a simple linear thing, then like each person's productivity is a perfectly defined function of all of the data one could see if you ran this sort of experiment, which is exactly what we're going to do. Okay, so this is the actual model that we estimate in the paper. There's three big buckets of utility: the income from your salary, the utility of output, and we've just plugged, we have a very simple Cobb-Douglas production function. The key, though, is that each researcher has their own TFP measure and their own, the gamma parameter, which is essentially how important is money versus your own time in your production function. And then lastly, the disutility of work. The constraints are that your total budget is going to be a function of how much guaranteed money you have, and then how much money you expect to fundraise given how much time you spend on fundraising, and then just simple, like you can only work 24 hours in a day kind of time constraint. So we're going to treat income, the guaranteed, and the duties as the state variables. You choose how to allocate your time. We're going to try to estimate some common parameters that govern the utility functions, and then the fun part is inside of the output is the parameters of each person's specific productivity function. The only thing I want to say about functional forms specifically is that unsurprisingly, we've learned through looking at the data that you do want to give duties its own parameter in the disutility of work function because before we were just saying all hours spent on work are equally unliked by scientists, and it turns out this fits the data much better if you allow duties to be very disliked, which I think fits all of our mental models of ourselves. But the key part of this is that we can get it right back to the illustrated example that I talked about, where the way that scientists choose between different job offers is going to reveal their productivity beliefs. Okay, so how do we get those choices between job offers? So in the survey, they're faced with a number of questions that look like this, which is basically the kind of question I mentioned at the beginning. If you had $1 million, if your institution is willing to give $1 million, but only if they cut your salary, how much will we need to cut your salary by to make you indifferent? Now, we don't actually use the word indifference because we learned that most scientists don't actually know what that word means. And so basically the way we say it is what's the smallest amount that could get you to take it. So it's not technically indifference, but practically speaking, this was the only way to get people to report something close to indifference. And you can see, we say like, look, right now, you've got $400,000 in guaranteed research funding, you're making $160,000. Now you'd have $1.4 million, what would be your new low salary? So we did this for funding. We did a similar exercise for administrative duties. We're like, now you gotta have more administrative duties, but they will pay you more. How much more will they have to pay you to take it? And we did this 4 times. So we did this twice for funding, where we offered people $258,000 and then $1 million. We did this twice for administrative duties, once where we forced more on them, and then one where we got rid of all of their administrative duties. One of the limitations, I'll probably say again, is that you can see we only have marginal variation for funding to identify the production function, but we do have both marginal and inframarginal data to identify the sort of time coefficient, but we couldn't figure out a way of asking people like how much would they pay to, how much would they give up if they could like lose some of their guaranteed funding. Every scientist we tried that with was like, that would never happen, it's mine. And so we just couldn't get inframarginal data on that. Okay, here are the distributions of just converting all of this into willing to pay, and even though that's like technically willing to accept a little bit on the right-hand side there. These are the distributions from whence the 10 cents and $68 came from. We have some graphs in the paper that show that as simple theory would expect, the proxies we can create for people's opportunity costs, like your implied hourly wages, correlate with these things positively in a nice, pretty straight line in a way that one would hope that they would, which gives a little bit of, it's the best we can do in terms of face validity of these measures. So, just to summarize, what we're doing here is we're taking scientists' willingness to trade off their salary for fewer or more inputs and use that to reveal how productive they think they are, holding fixed some other things, okay? Now, this is just some of our limitations about this approach. The benefit is that, as you can see, we don't have to take a stance on output or know exactly how to think about it. I think in your head, what you should think is that output is the thing from which scientists derive utility, okay? Now, but there are a lot of, we've jumped that hurdle, but there's like 10 more hurdles in front of us still. I think the biggest one is that obviously this is a non-incentivized stated preferences experiment. And with these noisy beliefs, but there is some truth to them. There will probably be some bias and also some noise. And both bias and noise hurt us because we're going to be thinking about allocative efficiency. And there could be a world where productivity is uniform and inputs are correctly uniform. But then, just because of noise, we estimate a wide dispersion of productivity, and then our model says you should spread out inputs, and you'd have big gains, and that would purely be driven by noise. And so that's going to inflate our gains from reallocation. Just a few other things. Again, I think the general takeaway of our limitations is that this is a conservative-ish upper bound of the gains from moving inputs around, which is not ideal. But I don't know. My prior over these sorts of things was super flat before, so. Hopefully, I can convince you that having at least an upper bound of the gains from reallocation is useful, because a lot of these things will push us to find larger gains than is probably true. Some good news just to counteract some of these limitations is we do a few exercises where we try to use our big vector of other variables in the survey, like household structure, all the socio-demographic data, all of the qualitative data on outputs, to try to explain the willingness to pay beyond what just the variables that are in the model. And all of those extra variables don't really add much explanatory power, in the sense that the model itself, just the variables there, have decent, R squared on the scale of 40 to 70%, and throwing in a big vector of other things, which you might think could capture heterogeneous preferences over the marginal utility of income or something, that doesn't add much information into the model. So that makes us feel decent that the heterogeneity in some of these other things may not be a huge concern, but it definitely looms large. And if anybody's interested about this benchmark good test, I can talk about it afterwards. Okay, so first, to just give you a sense of what our utility functions look like. On the left-hand side, and I've broken this up because of scale. You see the scale on the left-hand side, it's utils, is very different than the right-hand side for reasons you'll be clear in a moment. The big driver of utility, unsurprisingly, is just straight up income. People like money. The big negative driver of utility is duties. But you can see the disutility from higher duties is not dramatic relative to income. And just to be clear, what this graph is we're holding for each variable all of the rest of the parameters and variables fixed at their means, and just varying that variable from the 10th to the 90th percentile. So you can see the role it plays in the utility function. So those are like the big drivers of utility. Now in this tiny scale, which is like a thin slice of the y-axis on the left-hand side, you can see the different utilities from research output, and then the different inputs and the different time allocations. And again, you know, I think the not surprising but just intuitive takeaway is that the utility of having more and more research time, despite like this utility of labor, the fact that you can then consume the production means that on net you kind of increase your utility by spending more time on research. Now moving into the productivity parameters themselves first, and this is a bit of a face validity test. I'll get to in a second. Is just what are these gamma parameters look like of like how important is funding dollars versus your own time. This is the full population, and again, this is bound from 0 to 1. 0 is like the I just need my notepad. 1 is the I need a $10 billion laboratory to do my work. And you can see there's decent spread across the full spectrum, but most people are concentrated in this 0.4 range. I think this one is very intuitive, is that fields you think of historically as being very capital intensive, indeed, you know, the way people are answering these questions reveals that they do indeed need a lot of money to conduct their research. Economics is per this metric, the least capital intensive field in the set. Now to the slightly more interesting is our alphas, our TFP measures. And this is kind of our measure of like the marginal productivity of our factors, which is as close to like a scientist level productivity metric that I've ever been able to conceive of. And you can see it's very dispersed. Now, part of this dispersion, you're probably already thinking, like I said, is driven by a lot of heterogeneity across fields or across people along dimensions that we don't want to load into this TFP measure. And so then you can say, well, let's look within the broader fields or even narrow fields where perhaps the demand for researchers' output is more equal. And even as you move down into narrower groupings of fields, you can see that the ratio of the 90th percentile to the 10th percentile is still very large. Now, like for rough benchmark, if people don't read the TFP distribution in manufacturing firm literature, like usually you're playing with, I think, my read is like in the 1s and 2s and 3s, maybe 4 in developing countries. So per those, this is very large. Now, I don't want to make that comparison too strong, but just wanted to give you a sense that qualitatively, these seem like high degrees of dispersion. But again, you think of like a Rosen paper, the distribution of talent, like that's kind of what we should see when we're looking at individuals' own productivity. Now, lastly, I'll start. I'm doing good on time, Jacques?
Yes, I mean, you have, let's say, 5 minutes more.
Perfect. Thank you.
At most.
Wonderful. So now we have these parameters and we have our structural model and we can kind of move inputs around however we see fit. And so what are we going to do? We're going to manipulate two things that we feel like are things under the control of actual managers in the real world. The first is just the administration component of the duties, which in the model actually includes both administrative duties and teaching and like any other work that you're doing that is not research or fundraising. And then we're also going to manipulate the guaranteed research funding that each researcher has. I really want to get to a point where we can manipulate each researcher's fundraising productivity, which is effectively like a quantitative measure of how hard it is for you to get money for your research. It just turns out like mathematically, it's way easier to manipulate the intercept than the slope. So that's where we are. Again, because we don't want to read too much into a cross-field heterogeneity, we're going to do all these reallocations within fields. And then the fun part is that the model allows us to allow scientists to re-optimize their time allocations so we can think about something that's a little bit closer to equilibrium. Though, you know, you can't like change the way you're doing team structure and like the whole notion of teams, and that is very absent from our paper. The two objectives we're going to look at is first, like I said, maximizing scientist aggregate utility, and then second is social welfare. Now, we've been trying to think of a like not insane, parsimonious, but kind of realistic way of modeling externalities here, and what we've currently converged on is that social welfare is basically the scientist utility function plus a multiplier that kind of generates externalities from output. And what this effectively is saying is that like producer surplus is a fixed function of total surplus as output scales. It's like one way I've been trying to kind of wrap my head around what exactly that thing means. The other nice thing, it has a bit of an intuitive interpretation as like it governs the share of social value that scientists capture themselves. So if it equals 100, which we set it to in some of our counterfactuals, it means that scientists capture 1% of the marginal social value of their output. Now you're already probably thinking like, well, some of that output value is captured through their salary, and like, yeah, we haven't quite figured out how to incorporate that. The only thing I'll say on constraints, besides having some sort of practical constraints in the model, is that we do one version where we fix total budgets to be what they currently are, and then one where we leave total budgets unconstrained, and the only constraint in the system is scientist time. So just at a high level to give you a sense of what the model says, this is how inputs should look in the optimum compared to the actual if we're maximizing scientist utility. You can see, so this is a world where you want these graphs to both be on the horizontal line and no residuals. I'm just showing you the bin scatter so you can't see the residuals, but overall what this is saying is that the current allocation of inputs is fairly consistent on average with a model that maximizes scientists' utility. What you do see is that there are some people who the model thinks are all-stars that it really wants to get them to work a lot more on their research, but they currently can't because of their time constraints or their lack of funding, and the model tries to shift funding around to get these people on the right-hand side, these people right here, to work a lot. Because you see right now, on average, they're only working about 20 hours on the research, and the model says, you seem awesome, let's give you as much as you need to keep going. But just to summarize what we see in the counterfactuals, I don't want to lean too hard on these numbers because we're still, this is a bit of a work in progress, but basically when you move duties around, that seems to be a strong tool for manipulating scientists' utility. That's equivalent to about a 10% increase in salary. But funding is the thing that if you move around can make some pretty dramatic changes in total output in the sense that you can double the total output holding fixed the total amount of funding in the system. The interesting result on the budget constraint is that if you left the budget be unconstrained, like if the NSF was infinite dollars and the only thing was how much time scientists want to spend trying to get money, it looks like they would only fundraise about the total budget would only grow by about 20%, which I think is an interesting way to sort of benchmark the current size of the scientific market. And then lastly, on the social value, it depends on how much value you think scientists capture. If you think they capture 15%, social welfare goes up by 8%. If you think they capture 1%, it can go up by 60%, et cetera. I think maybe just to summarize, and I'll end here, is the model is indifferent between current allocations and a doubling of the budget, or current budgets and the reallocations, to give you a sense of the value of that gain. Okay. And with that, I will wrap. Thank you.
First of all, it is related to some things I'll talk about on Friday if anyone's still here, although I suspect you may all decide you want to go off and see the Louvre or something. But our paper is much more primitive. This is much more advanced, but it does closely relate. So I have some new numbers for the author. Oh yeah, the committee up there. I mean, just to keep you in touch with why you see me moving around. This is the reason. It's because there are many nice places to move to. Page down is this? Yes. Okay. So the presentation, of course, was really clear, right? So I'll just remind you that the first innovation in the paper is collecting this enormous data collection effort, which fortunately seems to be yielding more than one paper. So I'm very pleased to hear that. And it has potential, I think, for a lot of things. And then they combine this with a large amount of detailed information about the salary, time allocation, and funding for these researchers. And from this, they infer their private return from research in money terms, I mean, by dint of the questions they ask. Now, some key I think these are key assumptions for interpretation. The first thing is that the researcher's utility, which is UT, the income utility I don't have a problem with, the utility from research corresponds in some sense to research output. That's a good way to think about it, in my view. But I kind of thought what would be really interesting, so this is the next paper, would be to take the publications and citations, which is what I've been working with, and have a unobserved productivity variable and have 3 equations instead of just one. That might be even more informative in sort of trying to capture something about the value of the output, given the problems we have, trying to evaluate papers when not all papers are alike, et cetera, even when they're citation weighted, As we all know, and I'm very aware of, writing a good survey definitely produces citations. It may not be a magnificent research output. The second thing, and this is the thing that probably I'll try to say more about, but I put it in red because this is really the leap of faith in the allocation exercise, which is that the social value of research for all of these researchers in all of these fields. Now, he does it field by field, so that's good, at least we're, but still, the social value is a simple constant multiplier of researchers' private value. And that, I think, is a really strong assumption. And even though he does it field by field, and he does for different values of the shared omega of the social, that omega multiplying U2 is the only difference between the private value and the social value. Social value including, of course, the researcher's private value, right? I mean, that's why it's the only difference. And that omega, he does vary. I mean, they do vary, but still, we might think, I don't want to name any research fields here, but we might think that there are some research fields that might have more social value than others, as a share of the private value. Anyway, the bottom line is to use the results to evaluate the benefits of reallocation of research funds and time. Within the range, the support of the survey, more or less. They're pretty careful about that. And I think that's a really interesting goal, but I also think that the red comment needs to be solved before we really go too far with that. I can see Kyle nodding. I'm sure he's thought about this. So to go on to some, summarize the results. I mean, I thought the results of the survey were really interesting. They certainly agreed with, my priors, except that they're very extreme, and they're a little puzzling. $68 an hour corresponds to an annual salary of $136,000. The median salary in this survey is $140,000. So these guys, as many academics have told me in the past, would research for free, basically, is really what it says. And I suspect, there's a marginal average problem here, right? I mean, making that extension is a little much, but still, it does tell you that they really like the time to research. There's a figure that he showed, I think this was not, it's in the appendix, which basically shows that the salary across researchers is clearly correlated with this willingness to pay. The willingness to pay is about $50 more, as I read off the graph, more than the hourly wage, which again is almost, compensating it. And the final result at the end of the paper, if I read correctly, is that the biggest gains in social value come from the reallocation of research funds to more productive researchers. Okay, and you saw that in the graph. I mean, that was pretty striking, in fact, in that graph. Now, the new numbers I have for Kyle are, he reported a 90-10 ratio for researcher belief in productivity across all fields of 12.1 in the paper. So I went out and did it for we have a sample of all CNRS physicists during a certain period and all French university physicists. And I went out and computed the same thing. Because you said you didn't have enough, I mean, TFP of firms is really not the same thing, but this is pretty much the same thing. It's a different productivity measure, but it's meant to be at least correlated. The lifetime numbers are a little lower because my sample, and I didn't have time to do it carefully, it's truncated at 2022, so some of my physicists haven't finished their life. Okay, so that's why it's lower. But I did it for ages, the average for ages 40 to 50, which is around the center of his data. His median is 45. And many of his physicists are in that, his researchers, minor physicists. But my numbers are in fact bigger. They're 12 for the CNRS, which is a very selected group of high productive people who are fully funded. So they're really not the same as his group. The university guys I have a higher number, So these big numbers are not terribly, you know, the 90-10 numbers. And this is even after I exclude the people who, there are a few of them, who never do anything, right? I mean, I had their names, but they never actually, I couldn't find them or they never did anything. For the CNRS, there are hardly any of those. For the university, it's much harder because people specialize. They go off and just do teaching or something, and I never see them, you know. But I dropped those, and even then, I still have these big 90-10 numbers. If I didn't drop the university ones that did 0, both numbers would be infinite at 90-10. You know? So that's why I dropped them. Wouldn't be very informative. So finally, here are my thoughts. First of all, I'm not sure what it means if we start thinking dynamically, and I would hope Kyle would think about that, you know, in the revision. I mean, maybe it doesn't matter. I'm not convinced it's going to matter, but the research output in the utility, one of its contributions to utility is that it influences the salary in the future. And so, you know, at some level, the U1 and U2 have a relationship over time. And they affect the time allocation also. I mean, one of the ways you're getting returns to research may be that your future salary is higher. I'm not sure, I think it might reinforce the demand for research time, you know, but that's about the only thing I can, you know, I didn't work through the algebra. The bigger problem is, you know, university administrators are fond of telling the world that the best researchers are the best teachers, okay? This is something I've read many times. When you know what the story there is, you know. In the cross-section, that's probably more or less true. Within researcher, it's not. You know, I mean, some people are more talented than others, and they're more talented in both dimensions. But if they do have a substitution problem across the two. And so teaching is not in here in any sense except as a time consumer. And, you know, I think the social value of teaching may affect how you think about those guys who you'd like to give full-time, you know, you'd like to send to the CNRS, you know, basically, and give them full-time research support. Because it may be that you lose something at that point. Now, of course, graduate teaching is not really being considered here, probably. I mean, you know, or advising. I mean, that's a, you know, there's a big something going on there, which is probably captured by productivity, but by papers at least. But it's not explicitly considered. So anyway, that was my thinking about that. But so this, you know, it's the spillovers from benefits from co-production that I'm worried about. But I still think the biggest weakness is the assumption of uniform spillovers, externalities from research of any kind. I think another place where something like this could be really, really useful, the policymakers really struggle with the problem of how do you allocate research funds to the NSF across different programs, okay? And if you could get anything, eventually if you could get the spillover measure, which I think is really the hard thing to do, if you could get anything on allocation across fields using these data, because you have all the fields, that would be extremely helpful. So there's the long-run research agenda. So I'm telling you all the things you can do in the future, which I won't be around to see. Oh, and I do have one more comment which didn't make it into the slides, which you answered to some extent during the presentation. The alpha I is extracted from the willingness to pay coupled with some possible re-optimization in your model. Okay. There is a question in my mind whether the scientist knows how to do that. Yeah, obviously we always make this assumption that people can optimize. This is fine. But I'm interested, being female, I'm interested in the gender differences, okay, because I think they're there. And you mentioned the demographic sociological test that you did, but I don't think it answers my question. And I think you should run the whole thing, if you can, separately, and see if you get different answers. Because my suspicion is that the female perception that leads you to compute an alpha I may actually be different from the male on average. I mean, you know, there's a literature out there that says that the evaluation of one's abilities in this area does in fact differ, and you have a way of getting at it. So I think that would be, I think that would be interesting. So my final comment, I'm probably out of time, right?
Yes.
That it's a really interesting paper, and I think it's a big step forward. You know, I'm very happy to have had to discuss it. So congratulations. Yeah.
So I propose.